Alright everybody, let's have a little look at Desmos. So we want to transform our trig graph. So standard trig graph looks like that one. That's y equals sine x. The amplitude of my wave is just simply, and I might zoom in a little bit just so I can see it, is up and down 1. So from that middle line of 0, we can go up one place or down one place. So altogether it goes up a grand total of 2. But from my middle line we go up 1 and down 1. My wavelength is from the beginning of wave all the way to when it starts to repeat itself. Here it goes through 0 and 0, and here it goes through 2 pi and 0. So one wavelength is simply 2 pi or 6.28. Okay, so I'm going to transform my graph. I'm going to double it. So here I have y equals 2 sine x. So all I've done is double the height and double the trough. So the wavelength has stayed the same, but the amplitude or the height has changed. Let me turn that one off for a moment. Okay, so I'm going to do the same thing. I'm going to go y equals 2 sine x, but now I'm going to add 5. So I've moved my graph up 5 places, and I've also doubled the height. Wavelength is still the same. Goes from just on 2 pi, if I can get the exact right point. Wiggle, 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 wiggle. No, can't quite get it. Okay, so from 5, 0 to 2 pi, 5, 2 pi there. Okay, one wavelength where the wave starts to repeat itself. Or you can go from the tip, here a peak to the next peak. The difference between pi upon 2 and 5 pi upon 2 is 4 pi upon 2 or 2 pi. So I'm going to now make my wavelength different by doing this formula. And by dividing x by 3, instead of shrinking it, it actually extends it a bit. So I'm going to zoom out a little bit so I can see. Here's my wavelength, starting at 5, following one whole period to there. Okay, so not quite hitting 5. There we go, 18.85, which will be 6 pi. 3 times 2 making 6. Here's the 3 times 2 making 6 for now one wavelength. My height is still 2. My up and down movement of 2 from a center point of 5, which comes from the 5 I'm adding on the end. Right, the last transformation I'm going to make is I'm going to change the starting point, or the place where it crosses 0. By doing this, now I've got this minus 7 in here. Down here with my ordinary sine graph, it goes through 0 and 0. I know the center of my graph is still at 5, but my graph doesn't go through there anymore because of this minus 7. So in my sine graph, what makes that 0? Just a number 0. What makes this 0? The number 21. 21 over 3 is 7. 7 take away 7 is 0. So let me go over to 21. Okay, it was there. And I should find that that goes through 21 and 5. If I can get the exact point, there it is. 21 and 5. The 5 coming from the plus 5 on the end of the formula. The 21 coming from what makes that bracket 0. And the amplitude is still 2. So there's 5 simple transformations I've done to my graph, starting off with the ordinary one, going to the fully on transformed graph there. Okay, so have a practice, try this yourself, and see how far you can get.